Good morning, good afternoon, good evening, guys, girls and gentlebuds. Welcome back to the shed. Today, the one you've all been waiting for, hopefully. I'm going to make a start on stripping down the head for the MX-5 hill climb car. I've got a few bits ready. I'll switch the camera position over and you can have a look and I'll explain what I'm doing. Right, so I've got a few bits ready. I've made this support so when I take the valves out I can put them in the relevant positions where they came out of, so that when I put them back in, each valve will go back into its original seat position where it was. You can interchange them because they're going to be lapped in anyway, but it's best practice to put them back in the same positions they came out of. Now you might be wondering why I've got a claw hammer. That will all become obvious soon, and that piece of wood and this little monstrosity I will explain shortly. So that and that, and I've got a pair of long nose pliers and a valve spring compressor. So we'll move along to the cylinder head and I'll explain what this is about. Hold tight. Right, so I've got the head mounted in that wonderful stand that I showed you last time. And I can rotate it on the stand and lock it in a variety of positions. That is a problem. The MX-5 cylinder head, this particular type, is located with two tubular dowels that locate it exactly on the cylinder block. Unfortunately, whoever fitted this head last didn't locate it properly. And when he's pulled it down with the head nuts, he's actually pushed that dowel into the cylinder head, flush. Now because it's in a through hole, it's difficult to get out. That's what this is about. So it's just an old bolt. I've bored a hole through the centre and machined taper into it at this end and split it with a hacksaw blade. So that will go in through the dowel. Right, so I've got that in there. Hopefully now that is spread enough to grip underneath the dowel. Piece of wood on the surface so that I don't damage the surface of the cylinder head. And then I get the claw hammer in and any lever, and there we go. Out comes the dowel. Bit of a fiddle, but it works. Now there should be two of those dowels, one's missing. Luckily I have spares. But if you've got one of these heads to work on and the dowels have been pressed in like that, that's one way of getting them out. Maybe you come up with a different way, but that's the one that I did and it works. Well, it worked for me. Right, so before I start stripping the head, I want to check the surface for flatness to make sure that it's flat, not warped. If it's warped, it's got to go for skimming, and I don't really want to have to skim it if I can help it. Now this is an engineer's flat edge, so that's ground to be true and flat. So I place that across the top. Let me just turn that cylinder head one notch. So it's a bit more level. That'll do, that holds it nice and level. So I place that across the cylinder head and using feeler gauges, I go for the thinnest feeler gauge we've got, which is 0.038 millimeters. 1.5 there in old money. So all we do is just that won't go under that straight edge anywhere along the length of the cylinder head. So it's good in that spot, and move it down to the edge of the pots. That all looks good. Nothing there. That's good. Looking very promising, but we won't have to get the cylinder head skimmed, which is good news. That's all fine. That's good. The only places it did go in there and there is because there's holes there. Right, so check it across that way. That's good. Only really need to check between the cylinders across, because we've already checked down the length. That's good. That's good. The other way to do that check, you still need the straight edge, but instead of using feeler gauges, what you can do is place the straight edge along like that, and then shine a bright light on the one side of it and view the other side to see if you can see any light shining through, and we can't. So that head is nice and flat and true and doesn't need skimming. Good news. If ever you use a straight edge like that, when you're done with it, immediately put the protector back on the edge, because if that gets dropped or something gets dropped on it and it chips that edge, it's ruined. It's got to go back for regrinding to get it true. Right, so the next step is to start taking the valves out. So take the pin out, we'll rotate the head to about there, I think, and this is where you need a spring compressor, valve spring compressor, which I've got here already set up. So we pop that in there. Now this is the front end of the cylinder head, and the box I've got to put the valves on I've marked for front. So as I take a valve out, I put it in there in its relevant slot. Right. So all we do is locate that pin under the valve head, that one just screws down into the collet, and that will compress the spring and allow me, with a pair of long nose pliers, hopefully, to remove the collets. Have a tub ready to put these in. These are small fiddly parts, they're easily lost. They're a bit of a fiddle to get out sometimes. You may need to just wind the spring down a little bit further. So there we go, that's the collets. And now we can unwind the spring. Like so. And we can remove spring cap. Pop that in the tray. Now it doesn't matter about the springs being saved in exactly the same places. A, it's not that critical, and B, I'm replacing these with uprated springs anyway. So there is one thing worth bearing in mind with MX5s. If you're reusing these springs, you'll see that the coils at this end are closer together than the coils at that end. I've always found the closer coils are at the cylinder head end of the job, not the cap end. Whether it makes a difference, I don't know, but that's the way I've always found them to be, so that's the way I've always put them back in. So then we can push the valve out and we can have a close look at the valve. That doesn't look too bad. I did shine a light down the ports earlier to see if I could see any light passing between the head of the valve and the seat, and I couldn't. So I think these have all been seating pretty well. That looks pretty good. They will get lapped in, so that goes in the box. So I'll carry on and get all of these out, and I'll come back to you when we've got them all out. The rest is all just a repeat of the same procedure. Right, so that's the last one doing now, last exhaust valve. It's worth mentioning that sometimes it's easier to use a magnetic screwdriver to get the collets out than long nose pliers, although even then they can be a fiddle. One, and that's the last one. Right. We shan't be needing that tool again for a while. The spring cap off, pop the spring out, and then pop the exhaust valves out. There is very, very slight pitting on that, nothing to worry about, that would lap in nicely. When I say lap in, for those of you that don't understand the terminology, lapping in is the process of grinding in the valve by hand. We simply put some grinding paste on the surface of the valve there, use a stick, and we grind it in. I will be doing that later in this project when we're rebuilding. There's quite a lot of work to do between now and then. Right, so that's all of the valves out. Right, these wonderful devices, this wonderful tool is for removing the stem seals. We should be replacing those. They do have quite a tight grip on the end of the valve stems, the valve guides. Not stems, they're on the guides. And as I said in the last video, the guides themselves are being replaced in this head with phosphor bronze units. You've got to be careful when you're doing this, that when they do release, you don't smack yourself in the face. Trust me, it's been done many a time before. Spin him over and have a look what the ports are like. Try zooming in a bit, see if we can get a decent view of it. if I just move the camera slightly. There. So we're now looking at the exhaust ports through the valve seats. The seats look in pretty good condition. They'll lap in nicely. There's a bit of carbon still around there. I'm lucky enough that my business neighbour has a huge cleaning cabinet with a high pressure washer built into it that jets hot cleaning fluid at high pressure. It's like a jet wash but inside a cabinet, and it's a fantastic machine, and it strips a huge amount of rubbish and crap out of a job like this. There is still some carbon right at the bottom of the ports, but in general these heads are pretty good. They don't need a huge amount of work to improve the flow. Literally all they need is the surfaces cleaning up. These are just rough as cast, so literally all we need to do is clean them up, smooth out the surface, and that will give us a gain in performance. Right, there we go. So you can see there and there witness marks from where the seats were machined out to allow the inserts to be put in. In fact, if only you can see it clearer on this one, you can see where the milling cutter has cut away the original port surface, and what's happened is it's left a slight step there which will cause turbulence in the airflow, which affects the filling ability of that cylinder. Basically, an internal combustion engine is an air pump. The more air it can pump per rotation of the crank, the better it performs. That's called volumetric efficiency. There's several ways of measuring the efficiency of an engine. Volumetric efficiency is probably one of the most important ones, because the more air we can flow, the better the engine will perform, because it's the compressing of the air, and then when we ignite the fuel in there, that burns very rapidly, and the rapid increase in temperature causes a massive and rapid increase in pressure, which pushes the piston down. So obviously the more air we've got in there to compress and then expand with the heat, the better the engine will perform, the greater performance we get out of it. So we can clean up the surface in the combustion chamber itself. It's not too bad. A slight step there between the seat and the combustion chamber surface. We can smooth that out a bit. You can go bigger valves in these heads, but only by about 1mm. That's a ½ millimetre in radius, 1mm diameter. Simply because the existing valves are so close to the edges of the cylinder, and you can see around here the seat is very close to the edge of the cylinder, and it's what's called shrouded. So bearing in mind that the cylinder wall itself is very close to that edge, this quarter of that valve and this quarter of that valve is going to flow very little air because it's through a very narrow gap. The valve is said to be shrouded. So there's a little bit of work we can do there to improve matters. None of these jobs in themselves will release huge amounts of power. What they do, they all work together towards improving the airflow and therefore the volumetric efficiency and therefore the power that the engine can produce. I think I'm going to leave it at that for today. I've got some cleaning up to do before we start dressing these ports up, and I need to decide whether I'm going to try and change these valve guides myself or farm them out to a machine shop. might be better to pass them on to a machine shop to do, because it's a job I've never actually done before. I understand the theory, but it's one of those jobs you actually only get one shot at, and if I get it wrong, it's going to cost me more money than it might do if I just chuck the cylinder head and the new guides to a machine shop and say, swap those for me. So we'll leave it at that for today. I hope you found this interesting and helpful, and I'll see you next time. Cheers.